This module will give you an overview of databases. Almost all of the applications we use, regardless of which digital devices we use them on, need to store data in some way. And in some cases, this data is easy to understand and is stored in individual files. For example, the camera app on your phone creates a new file called a JPEG for each picture that is taken. This is short for Joint Photographic Experts Group File, which is a special format used to store photographs. You can see each of these individual files stored in your photo gallery. Another example would be a word processor, for example, Microsoft Word or Google Docs. Each new document you create is stored as a separate file. You can easily see the document files you've created on your local hard disk or on your cloud drive. Now, all applications are quite so simple. Often, digital applications want to be able to link different data together. For example, a social media app wants to be able to link you with all your friends. An online store wants to link you with all your past purchases and recommendations for future ones. Storing data in separate files doesn't work for these kinds of requirements. What is needed here is some kind of database. Databases are a really important part of most computer-based systems. You may not realize it, but you probably interact with databases every day. Every time you log onto a web page, for example, your social media sites, auction sites, your online banking, or your media streaming services, some part of the system is looking your details up in a database. If your school is using a learning management system, you will have a database running behind it to store important information about its contents and users. Databases can be structured in a number of different ways, but the most popular types of databases store data in a set of linked tables. Perhaps the most important aspect of a database is that the data inside it can be queried in many different ways. A database query is basically a question that we ask of the database, turning data into useful information. For example, if you ask a mapping application on a mobile phone to tell you where the nearest supermarkets are, it is a database query that provides the required destination. The database isn't on your phone, it's out in the cloud somewhere, but the query goes from your phone to the database, carrying information about your location and the type of places you are looking for, and the information is sent back. Something similar happens if you connect to an online store. You might choose to search for an author that you are looking for in the book section. Again, a query is sent to the database using your search terms, and the relevant list of books is sent back. There are many tools that can be used to create databases like this, but in the example we're going to show you, we've chosen to use Microsoft Access, which is very easy to use. We're going to demonstrate a very simple example that has two tables and goes through some examples of how we can query the data that has been stored in the database. The database we have created for this example contains some details about the top 10 movies of all time. There are plenty of different lists on the web using different criteria for what makes a top movie. This particular list is taken from the Rotten Tomatoes Top 100 Movies list, which, unlike many others, includes the awesome Paddington 2. Of course, databases in the real world can contain large numbers tables, and huge amounts of data, so our example is very tiny in comparison. The two date tables in the database are movies and stars. Each of these tables contains a series of date records. A record is the information about one of the things in the table, such as a particular movie or a specific movie star. Each of these records has several fields. A field is a single piece of data, such as the surname of a movie star or the name of a movie. Here's what the movie table looks like. It has 4 fields: movie name, year released, genre, and director. Here's the star table. It has fields for the name of the star and related dates. What makes this database interesting is that each movie contains more than one star, but a single star can act in more than one movie. It is this type of many-to-many relationship that databases are good at representing. To make this work, the database contains another table that links movies and stars together. But that's just an internal part of the database that we don't need to worry about here. Let's look at a couple of database queries that use this data. Microsoft Access has a feature called Query by Example, where we can easily create database queries by selecting the data that we want to show and the selection criteria that we want to apply. Here's a super simple query that just uses the movie table. Note how we are just looking for records where the genre matches horror. Here's the result. Both horror movies are in the list. This query looks for all the stars who acted in the movie, All About Eve, and uses both tables. And here's the result. In contrast, this query shows all the movies with living stars. A bit more complex, but the search is null, just checks if the died field is empty. And here's the result. There are many more things you can do with a database, but hopefully this little example gives you some idea about how useful databases can be in providing us with the information we want from large amounts of data. Thanks for watching.